right, this is a question about forces. The scenario we are given says you have a basket filled with baby doll arms and you're bringing them to be recycled. To haul the baby doll arms, you must push the basket up a ramp or inclined plane, in this case, to get it into the back of a truck. So this is our image of the inclined plane, and we're given that it's got an angle of 25 degrees. And then this is our basket of baby doll arms, and we're given that it has a mass of 33 kilograms. And the question we are asked is, what is the coefficient of friction between the basket of baby doll arms and the surface of the ramp? First, we're going to draw our forces, our diagram. And so we're going to have, let's see, this is the block, the basket, I'm sorry. Then we're going to have a normal force we'll say F sub n, and going the opposite direction of the normal force is our perpendicular force, and pushing up this way, the applied force is going to be F parallel. That's what I'm drawing there, F parallel. And then the force that's not helping us push the basket up the ramp is your frictional force. So I'll draw it like down arrow, F sub F. We'll say that, frictional force, F sub F. Also, we know that we want this to be our x-axis because it runs parallel with the surface of the plane. So we'll say that's the x-axis. So opposite that, we've got our y. And that's with the normal force on it there. Also, we have our gravitational force, which is going straight down. Doesn't matter where your x and y plane is, gravitational force is always going to go straight down. And gravitational force, we know, is W equals the mass times gravity. All right. So now we also know that that when you're pushing the basket up an inclined plane, we have a constant velocity in this case. Constant. Can you see? Okay. Constant velocity, which implies that the applied force, F sub A, is the same as the frictional force, or the parallel force, we could say. And so if the force applied and the frictional force are the same, then what is the coefficient of frictional force? That's what we're looking for. Or this is also like the stickiness of the surface between the two objects. So if we know that in the, let's see, the summation of all the forces on the x-axis, which is right here, that's going to be, what do we have? Frictional. We have frictional force this way, so F sub F. And we have to subtract what? Parallel force? Yes. minus parallel force. And it's going to be equal to 0, right? Because we're at a constant velocity. Alright, and then we'll go ahead and put our y, set up our y over here. The summation of the forces on the y-axis is going to be, what forces do we have at work? We have normal force, F sub n, and we have our perpendicular force, so say minus F perpendicular, and that also equals 0. Again, constant velocity. Alright, now we can express some of these things in terms of our mass and our angle. You know, our angle here and our mass here. If we set up our vector diagram, which we have here. So let's see where our triangle is at. If this is here, then we have, right, going this way, we have our F perpendicular. It's going down that way. Then we have, right here, we have our frictional force, right there, friction, F sub F, frictional force, and then we're going to have our hypotenuse, right there, and this is our gravity. Mass equals W, alright, yeah, and so this is our 25-degree angle right here, and if this is our right triangle, then we know that we want our hypotenuse, and we want our adjacent. Yes, our hypotenuse and our adjacent sides whenever we're dealing with the x. So, and that's cosine, obviously. Yeah. Oh, I'm sorry, adjacent over hypotenuse. So we want that over that, right? So we're going to use cosine. We're going to say, that F perpendicular equals the weight times cosine 25 degrees, right? So cosine is the one for that. So sine is going to be the one for the other. We'll say F frictional force, that's the other one, right? W sine 25 degrees. Okay, cosine, sine. Alright, and so our mass, let's go and find W. We know up here that our mass is 33, so we'll say W equals 33 kilogram times 9.8 meters per second squared. And we come out to, where did I write my calc? 323.4 newtons. Because kilogram times meter per second squared is newton. Alright, so now we have the W. Let's go ahead and put that in here. And we'll find F sub F, frictional force. And we'll say, right here, 323.4 sine 25 degrees. We'll come out to 293.1 newtons. Alright, right here, let's do this here. Wait, what do we have? 0.4 cosine 25 degrees. And we come out with 293.1 newton. Alright, and so if velocity is constant, then we know this frictional force is equal to what? The coefficient times the normal force, right? So we know this right here. We need to find this, and we should know that the normal force is going to be equal to what? Our perpendicular force, right? So, and we know our perpendicular force, so let's go ahead and plug that in. 293.1 equals mu 136.7. Let's get mu by itself. So coefficient of friction equals 293.1 newtons over 136.7 newtons. Newtons cancel. And we're going to get, it's approximately 2. It's like 1.9, but approximately 2. And we know that this is a pretty high coefficient of friction, and it means that the surface is very rough. And this would actually, it would require a lot of force to overcome the frictional force, which is kind of good because while we're trying to load the truck with the basket of baby doll arms, we don't want to slip and fall. So there you have it.